For thousands of years, the course of exploration had been determined by staring toward the stars and moving forward with bold progress into the vast unknown.
Astronomy is the oldest science. People have been looking up at the stars since we sort of stopped walking around on our knuckles. The way astronomers become interested in astronomy to begin with is just by looking at the sky.
If it's happening outside of our atmosphere, comets, asteroids, planets, stars, galaxies, cosmology, the study of the birth, life, and fate of the universe, that's what we worry about. And we use the laws of physics as discovered here on Earth and apply them to phenomena in the cosmos.
Humanity reached out and explored farther and farther, until a place once reserved for the imagination and the distant view of a telescope's lens was now walked upon by humankind.
That's one small step for man.
I had to run outside and look at the moon and say, you see that thing? Well, there's people on there right now.
One giant leap for mankind.
It was 1969 as ticker tape fell from the sky and rock and roll blazed across the American landscape. Explorers started serious planning for a new type of telescope.
America loves discovery. That's in our national DNA. When Lewis and Clark was sent out on their expedition by a president of the United States, it was called Discovery. And that's when we send out our astronauts. That's when we've now sent out a space telescope to go where no other telescopes had gone before and to see things that had never been seen.
So astronomy is about exploration. It's what NASA does. NASA explores.
A telescope that would go beyond the atmospheric limits of the Earth. It's a simple problem. When you desire to look at objects far away, there are limitations. Through technological advancement, you can remove these limitations. The handheld telescope supersedes the naked eye. That small glass telescope was replaced by larger models. Then mirrors are added, and then more advancements. As the size and capacities of the device grow, so do the discoveries. From mapping a few heavenly bodies circling the sun to seeing beyond ours and into other galaxies.
Before we ever put, men in space, astronomers are already thinking about getting, off of the planet above the atmosphere in order to get the crystal clear view.
But obstacles such as atmosphere, clouds, light pollution, and even our own sun's brightness stand in our way of seeing things clearly or watching around the clock. The solution? A non-ground-based robotic observatory.
Well, there's that famous song, Twinkle, Twinkle, Little Star, How I Wonder What You Are. That left a lot of people thinking that twinkling stars is exactly what astronomers want, but is the opposite of what we want.
One thing I've noticed as an astronaut is that when you get into space and you look at stars, they don't twinkle like they do on Earth. What you're seeing when Twinkle, Twinkle, Little Star is because the light is coming through the atmosphere and causing them to twinkle.
Starlight does not twinkle on its own. It twinkles coming through Earth's atmosphere. And it's that bump and grind and jiggle and wiggle moving through the layers, different temperature layers of the atmosphere that disrupts the precision of your imaging of the night sky.
A space telescope was thought of originally by Lyman Spitzer, had the idea that if you could get above the atmosphere, you could see a lot more clearly.
Renowned astrophysicist Lyman Spitzer gathered support in the astronomy community for a large space telescope, which later on would be named in honor of astronomer Edwin Powell Hubble. It was Hubble who discovered the universe was expanding. Through the lens of a 100-inch telescope, he made calculations that the universe was made up of billions of galaxies, well beyond the visible Milky Way. His observations pointed out that these galaxies seemed to be moving away from us.
We're 30,000 light years from galactic central point. We go round every 200 million years. And our galaxy is only one of millions of billions in this amazing and expanding universe.
Using known stars to calculate distances between galaxies, Edwin Hubble confirmed this galactic retreat.
But let's take it even further back. A lot of people don't realize this, but the Hubble Space Telescope was dreamed up by Lyman Spitzer back in 1948. And he wrote a paper on the advantages of putting a telescope in space to get above the atmosphere, etc. And that started a lifelong quest by Lyman to get the Hubble Space Telescope up there. He fought with the Congress with the able help of John Bacall, who I consider the granduncle of Hubble, both at Princeton. And he and John fought with Congress and convinced Congress to provide the early funding in the late 70s.
It looks out at galaxies and brings them to us, crosses vast distances that we don't have the technology to travel, but we can travel in a time machine using the Hubble to show us what the universe was like 13 billion years ago with the light that it pulls in, and also exposes us to just how vast the universe really is, with billions and billions of galaxies full of billions of stars.
To build a telescope, in many ways, is a decision to build a time machine. The United States Congress approved a large space telescope in 1977, sparking work to begin on creating this large, complex, and capable orbiting telescope.
Well, it wasn't easy. It was a long slog, difficult politically at first to have it accepted and funded in the U.S. Congress. And then technically it was difficult.
We need to find a new way and a new technology to approach the development of expensive satellites that would go to orbit that could somehow take advantage of human repair and perhaps the space transportation system.
An advanced international observatory with multiple tools, multiple cameras, instruments, and capabilities.
It's an amazing machine. It can orbit around the Earth at 17,500 miles an hour. And the reason it can take all these great images is not only because it's above the atmosphere, but because it can very steadily hold its gaze on an object in space.
Aerospace companies came in with proposals for a space telescope, a large space telescope. All of them had men riding around with the telescope. This was the last thing that astronomers wanted. In the first place, we were trying to get rid of the atmosphere, and a man needs an atmosphere. In the second place, a man's going to wiggle. I don't care how careful he is, where when you're taking a half hour or an hour exposures, he's going to wiggle sometimes. And when you wiggle in space, the spacecraft wiggles the opposite way.
A globally connected telescope built through a partnership with the European Space Agency, which would look into the stars well beyond international borders.
It takes a lot of people. It takes people that, obviously the scientists to conceive of it. It takes engineers to design it and build it and test it. It takes technicians to actually build it. It takes the people to keep the rooms clean, the facilities up and operating. So it takes people from every walk of life in order to do it, every skill set that you can think of.
To then place this telescope into orbit to send back to us the data that scientists needed, unobstructed and unencumbered.
And when it was launched in 1990, it really opened a new vista on the whole universe simply by enabling us to get sharper images above the atmosphere.
Humanity's always looked out there to the heavens to get the meaning of the hope of the life here. So you look out there for what's going on down here. People understood that about Hubble before we carried it up there. And so that's the magic.
And at the time, I was what we call the PLT, or the pilot, for the Hubble deploy mission, which was STS-31 aboard the shuttle Discovery. All of us in the crew had a certain feeling of exhilaration and excitement. We knew that this was going to be an important mission.
2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
On the 25th of April, 1990, the Space Shuttle Discovery, piloted by a future administrator of NASA, deployed the Hubble Space Telescope into an orbit around Earth.
Discovery Houston, you have a go to open the doors.
Roger, Houston. The mission itself was pretty intense in training, because we had to train for any number of contingencies that we all prayed would not happen.
Morning, Story.
Good morning, Discovery. Good morning from Bill Reeves and Orbit 1 team, and you got a go for HST deploy ops.
And Houston Discovery, The transferred internal power is complete. The umbilical is dead-faced, and we'll be standing by for your go for umbilical release.
It was the people's instrument long before we launched it. So, like I said, I was the lead communicator in the carry up and deploy mission STS-31, but it was the people's machine then.
That's outstanding. Thank you.
Ironically, one of those contingencies was failure of the solar array to deploy. It took us much of the day for the flight control team to say, look, this is not working out. We don't think we're going to get the solar arrays deployed. All of a sudden, this great experience turned out to just go, this is not good.
Shift supervisor.
When the ground control team calls, says, stop, we think we found a solution, just stop where you are. We're going to try this, and they did, and it worked, and so we went ahead and deployed.
Deploy activity so far is going very smoothly.
Okay, they copied the story, and we're
It all worked out because of the incredible work of the combination of the crew on board, the flight control team in Houston, but most especially very smart people at the Goddard Space Flight Center who actually knew the Hubble Space Telescope about as well as any people around.
GC, go. Network, go. Payloads, waiting on you.
Flight payloads, we are go.
Capcom, we have a go for release. Discovery, go for Hubble release.
Houston Discovery.
Go ahead, Charlie.
Okay, Story, we've been taking marks. Residuals and ratios look good, and we'd like to go ahead and go to filter state.
We concur, Charlie.
We launched Hubble April 24th, 1990, and we were all on top of the world. Many of us astronomers had never done an interview, and suddenly we were on Today and Nightline and Good Morning America, etc. And the media loved us. The Hubble was big news across the country. Everybody loved us.
And it's here, 381 miles up, where the telescope is to be placed in orbit tomorrow. So the celebration will continue.
Oh, yes. Hey, I get to launch something here, guys.
Westfall's family, neighbors, and colleagues who had traveled here from California toasted the telescope.
The science that is astronomy would never be the same.
When people think about a telescope here on Earth, they think about a mirror with a tube around it, and that's exactly what Hubble is. It's a huge mirror with a huge tube around it in space. And of course, the purpose of Hubble is to take these beautiful images that we learn about, and so the images are recorded on cameras, and then the data is sent back to Earth for us to study.
The Hubble Space Telescope powered up, all systems nominal, and the data began to stream in. Images of far-off distances, galaxies and stars, but there was something wrong. The magnificent space observatory's imagery was not clear, not crisp.
As a member of the deploy crew, we had come back, done our debrief, and we had done our job, and so we were happy. We thought everything was okay until the word came that we saw the first light images, and to the amateur like me, it looked great because we had made this great discovery right off the bat. What we thought was a single star turned out to be a binary star. When we learned that no, it's not really that good an image, it's kind of blurred because we have this thing.
From an agency perspective and from a public perspective, and a congressional perspective, it was doom and gloom.
But working on a bipartisan basis, we used the best tools to identify, was this a techno-turkey that we would just bag as a terrible mistake and say bye-bye boondoggle, or were we really going to try to fix it?
Couldn't get the telescope focused, had trouble pointing it sometimes. And that went on until about early June when smart people finally figured out that what we had was sphere collaboration.
The mirror was polished incorrectly. And it wasn't by much. It was half the thickness of a human hair across 100 inches. Now, you try to imagine how much sag something that weighed 2,300 pounds would have, and yet we were off by half the thickness of a human hair from center to edge. And that's pretty astounding that we could come so close and yet not make it.
The mirror was still a perfect smooth curve, but it had the wrong prescription. It wasn't the right curve. Just like my eye is a perfectly good eye, it's got a smooth curve to it, but it's the wrong prescription. Light doesn't come to a focus at the right spot. So how do we fix it? Well, we fix it with corrective lenses, the opposite prescription. And that's what we talked about on the famous press conference of June 27th, 1990, where I had the unique honor of explaining to the American people and the press that Hubble wouldn't be doing the science we had promised.
I'm going to try to give you a perspective on the short-term ramifications of this particular issue and also the long-term ramifications in terms of what we can do, the science we can do, the science we won't be able to do for a while in the short term, and most importantly, the solutions to this problem in the future.
Decades of planning and hope seemed extinguished by a blurring spherical aberration in Hubble's primary mirror.
We feel that we can characterize the problem, the spherical aberration problem, well enough that we can take advantage of an insurance policy that we haven't talked much about, and it hasn't been in the press much, and that is we started a long time ago to plan a maintenance program.
The truly remarkable feature of the Hubble Space Telescope is that it was designed to be upgraded and fixed.
On Earth, you'd order a replacement part and correct the problem when the shipment arrived. But Hubble was over 340 miles from the Earth's surface, moving at nearly 18,000 miles per hour. You'd need a special repair team.
The team comes together through multiple domains, multiple disciplines, and multiple organizations, multiple divisions. You got to get a job done. And NASA is absolutely expertise on this. When you got to get the job done, the team comes from many different places.
When Hubble was first launched, it had the spherical aberration on its primary mirror, so the prescription for the mirror wasn't right. It took a team of people to figure out what that prescription actually was in practice as opposed to what it should have been, and then people to figure out how to actually solve Hubble's blurry vision at the time. This institute and NASA and its contractors figured out a way to put together a prescription for correcting that spherical aberration.
After those two failures, the big boss came over and looked at me and said, "Story, fix it." Okay, I'll fix it.
1, 2, and we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
The real magic on the Hubble mission is almost 40 hours of spacewalking, and we had almost no surprises. We had 13 major systems to fix, and day after day we just kept working away, getting the system fixed, and they tell us this one is up and running and it's fixed. And we kept on going through 5 days, and finally we finished the job, and hey, it's totally restored.
Because astronauts from NASA have been able to go back and refurbish it, put in new instruments, repair it, so that 25 years has made it an increasingly more powerful telescope. And it's the fact that Hubble is so powerful today, which is so remarkable after 25 years. It's basically 10 to 100 times more powerful than when it was first launched.
Crew members, women and men in white spacesuits, rolled to the rescue like a great Western. And so this was a huge deal for me personally as an astronomer, astrophysicist, and astronaut to have the privilege going to Hubble on my first mission in 1999.
Like taking the car in for an oil change, rotate the tires. So we were changing out batteries, we were changing out the gyros, things that just made the telescope work.
So you have a satellite out there, and you got to maintain its attitude, and you got to maneuver to point very closely. The only ultimate force that you impose on the machine is magnets. Now, as Hubble goes around the Earth, here's the magnetic field of Earth, and the magnetometers, which I replaced. Those magnetometers, they sense where the magnetic field of the Earth is, and the computers say, okay, I'm going to turn these magnets on or off, and that's the way I'm going to control Hubble attitude.
Remember, up in space, there isn't anything for Hubble to push against, so it has to push against something internal, like these spinning wheels.
I did a mission to the Hubble Space Telescope, and it wasn't really a refurbishment. It was a rescue mission, because the Hubble telescope uses gyroscopes to determine how it's moving and how to point with absolutely no motion at a star. And those gyroscopes, 6 of them, were failing. And then by the time we got there, only 1, I think, was working. And so it was a dead telescope at that point. And our role on that mission was to basically repair the Hubble telescope. It was a real repair mission, just like the first repair mission to change the optics. If I had messed that up, I would be the one that had broken the telescope forever.
This amazing telescope with all this history, and what if I wreck it? What if I do something bad?
Then I got the opportunity to go a second time as the payload commander on STS-109. And when we actually were doing the spacewalks, and I went out and shook hands with Mr. Hubble, the telescope, holding on to the side, I truly felt like, this was my partner, and that we were here, to help.
I guess that's part of the excitement of having worked a Hubble mission, because you've got the best team on the ground, best crew upstairs. It's exciting, but there's a level of confidence you're going to pull through this.
It's incredible the things that they can come up with, and they have the time and the resources to develop that here, and then we take, sort of the best solution up with us to implement in space. There it is. It looks exactly the way it's supposed to look. It's exactly where it's supposed to be, and I'm just going to reach over and grab it. So it was a really good feeling. And what we did after we grappled the telescope and put it in the payload bay was every day that the spacewalks were going on, which was the 5 days after we grappled the telescope, the two guys go outside, and one of them is pretty much always on the end of the arm.
4-3, bueno. Copy, both 3.
So we drive them around and put them in position to do their work.
You are clear to continue and increase the rate out. Yes, you can increase the rate, Megan.
Copy, picking up the rate.
What a beautiful view.
They'd ask me to bring them in closer, move them by the telescope. I'd have to ask them, hey, you need to check and verify how much space do I have? And of course, their mind is on their job, the instrument that they're holding, the tools, whatever. And so having to work that coordination, training really helps there. But it's delicate in the sense of you don't want to hurt the hardware, you don't want to hurt the person, and you certainly don't want to hurt the telescope.
You can stop there, Megan. Mission stop. Thank you.
It was 19 years old at the time when we went up there, and the batteries were original equipment. And so they're charging and discharging, like think about your phone, your cell phone. You're lucky to get a year or two out of that battery, right? So this is original battery, so we replaced the batteries. Those are still working great. But then some of the more interesting parts were actually replacing some of the science instruments. So we took up a new camera and a new spectrograph and put those in. And then we also fixed some broken instruments up there. There was a broken camera and a broken spectrograph. These are the science instruments, so that when the light comes in the telescope, these are the things that take the pictures and do all the science for the astronomers and everybody back here on Earth.
The breaking off of one of the hand tools that Mike Massimino had to do.
Houston, you ready for this? Yeah, we're ready. Okay, man, you have a go. Here we go. So, disposal bag, please.
It was pretty exciting watching that from inside because that had a lot of bearing on whether we got that part of the mission accomplished, so it was pretty interesting.
A third time I got to go back, and I just can't tell you how thrilled I was, and how thrilled I was that we had a great team and we were able to leave the Hubble in even better shape, such that now we're able to celebrate the 25th anniversary. I was a little bit worried that when we deployed the Hubble, I'd feel really sad again, but this time I didn't. I just felt thrilled that we hadn't broken the Hubble, that we'd upgraded it, that it was in the best shape of its life, and that we'd done our job and a little bit more to give Hubble a very long life, bringing back all of its rewards to us here on planet Earth in terms of great discoveries.
The fact that astronauts were able to go up and fix Hubble was really a groundbreaking thing, and it tells a really critical part of NASA's history when science and human space exploration work together really critically for the first time.
Without the repair missions, you wouldn't have Hubble lasting 25 years. Hubble's best days are still to come.
Astronauts and support staff on the ground had made tremendous improvements to Hubble's already majestic payload. With the repairs completed, Hubble blew the world away with what it saw, and what we now could behold: sharp, clean, and crisp data. Images of stars forming and ultra-deep field images of thousands of galaxies, showing just a glimpse at how big this universe is.
I do have a favorite Hubble image. I have a couple of them, but the one that pops into my mind is the Cone Nebula, and it's an early release image. And the reason I like that is because it showed that we installed the Advanced Chemical Surveys correctly.
Hubble has brought just knowledge of the universe that I think is beyond belief to the normal person, and some of the discoveries of the Hubble Space Telescope in terms of the universe expanding are just mind-boggling.
Every time I look at it, I stare and I stare, and I want to see what's in that finger, what's in that pillar. And interestingly, if you look at it in the infrared, you can actually see into it.
The Hubble Ultra Deep Field was released in 2004 when I was in grad school, and to this day, I really remember the day when that image came out. My grad advisor printed this image, this beautiful image with galaxies that we'd never seen before, on a huge sheet of paper, and rolled it out on the table for us grad students to look at, and just said, look at this image, look what's here, what can we learn from this? And so I really loved that visual, sort of tangible representation of look at this beautiful thing and what can we learn.
Circling the globe at 5 miles per second, this school bus-sized observatory was the most technologically advanced device ever launched, and has stayed amazingly advanced through 5 repair and upgrade missions. From the first mission-critical optics repair on Space Shuttle mission STS-61 to the last servicing mission, STS-125, which added the Wide Field Camera 3 and replaced or improved sensors, batteries, and numerous other components.
Hubble was an incredible undertaking. If I look at the very last Hubble servicing mission, STS-125, it was perhaps the most ambitious single mission that this agency has ever undertaken. It was 5 spacewalks, back to back to back to back to back. That's no break in between the spacewalks like we normally will do. The magnitude of the things that they wanted to accomplish almost meant certain failure somewhere. But the crew said, the crew and the whole team, the team that put the mission together said, look, we can do this. We will have accomplished so much more in making Hubble better than it is ever believed to be. So Hubble gave us an excellent example of people, a team that was not afraid of failure.
Failure was not an option. We were going to succeed.
What's really exciting to me is just the breadth of the scientific discoveries it's been able to make. Everything from the age of the universe, proving the existence of black holes, to discovering brand new things, like the universe is accelerating due to mysterious dark energy.
I grew up, telescopes put into orbit wouldn't last more than 3, at most 5 years. So they never had a chance to grow on you, to become part of your soul of expectation for the next astronomical discovery. With Hubble, the fact that it was repairable meant it could just stay with you for decades, now 25 years.
Everybody knows Hubble. It's really true. Worldwide, all throughout the US, everybody, all ages, all walks of life, you say Hubble Space Telescope, people know what you're talking about. That's extraordinary.
More than a simple telescope, Hubble is humanity's grand observatory of the vastness of space. And we've kept exploring by staring into the universe and moving forward.
The great thing about Hubble now this year is that it's still going strong, and we expect it to last out till 2020, maybe even longer. But we definitely have to start thinking about the future. And NASA right now is building and putting together and testing the James Webb Space Telescope.
That's going to be put even further away from the Earth than Hubble, and be able to see much further into the universe and provide even more information and even better images. I think that's going to be very exciting when we get down into space.
The team here at NASA will continue that momentum, with the next great observatory coming soon to the NASA inventory, the James Webb Space Telescope, with a primary mirror 6 times larger than Hubble's and over 100 times more powerful.
There are places that the Hubble just can't see. The Hubble Space Telescope can't see inside the dark cocoons of dust and gas, where baby stars are born and planets form. The James Webb Space Telescope in the infrared will be able to peer into those cocoons and show us the details of those first moments of star and planet formation.
The big thing is how exciting space is for the future. It's going to be incredible. We're at the cusp of a new era with new machines being designed, new missions being flown. We are going to visit other planets, and I just hope the young people can get excited about taking us that next step. I can't wait to watch them do it. It's a great time.
Growth in space for kids that are involved in science and technology. I think space is a great way to aim your career at. I think we're gonna discover new things. I'm really excited that NASA's got a number of programs going, including the James Webb Telescope, which will bring the same kind of discoveries Hubble has. So the future's pretty bright.
Today, Hubble is still making new discoveries, seeing distant stars and galaxies that had never been seen before, improving our knowledge of the early universe, and clarifying images of our closest neighbors.
Look at the Washington Post. On the front page of the Washington Post, there's a colored picture of a brand new galaxy just discovered by Hubble. And to be able to look at that picture and say, by gosh, we did that. That's exciting. That's exciting.
Hubble has consistently taken us to places we've never been, visually, of course, and empowered us to answer questions that in a previous generation of telescopes we couldn't even pose.
From comets and asteroids to some of the most distant galaxies yet discovered, Hubble continues to revolutionize astronomy in our solar system and beyond. Hubble has changed the way we view our universe and ourselves.
There's no doubt that the Hubble Space Telescope has changed the way that we as astronomers understand the universe. But I think even more significantly than that, Hubble's changed the way that the world views space.
You know, when you look back on the last 25 years of Hubble, it's just incredible because we have made major breakthroughs in almost every field of astrophysics, from planetary nearby to our own galaxy to the very, very beginning of time. And to think that we mere humans are sitting here and getting close to understanding this incredible universe that's around us. And Hubble has been a key component in that over the last 25 years.
We're on a never-ending journey, and the Hubble Space Telescope celebrates its quarter century of exploration as part of that journey.